Welcome back. We are going to explore computational geometry in Python, the field that brings geometry and algorithms together. So, what is a computational geometry? Computational geometry is a branch of computer science that focuses on designing efficient algorithms to solve geometric problems. Example: finding distance between the 2 points, detecting line intersections, constructing convex hulls around points, performing spatial queries like which point is the closest. Applications of computational geometry: computational graphic and game design, robotics, geographic information system (GIS), computer vision, and CAD and systems simulation systems. Python libraries for geometry. Python makes geometry easy with a few amazing libraries like math for trigonometry and distances, shapely for geometric objects like points, lines, and polygons, scipy.spatial for algorithms like convex hulls and KD trees, sympy.geometry for symbolic and algebraic geometry. Points and distances. The most basic geometric element is a point. You can easily calculate the distance between 2 points using Python's mat.distance. Working with lines and angles. Now let's talk about lines and angles. The sympy library lets you define lines, find their equations, and calculate intersections or slopes. This gives you the mathematical equations of the line through those points. Polygons and areas. The Shapely library shines when dealing with shapes like polygons. You can easily calculate area, perimeter, and perform operations like linear intersections and difference between the shapes. Convex hulls. A convex hull is the smallest convex shape that contains all your points, like wrapping a rubber band around them. You can compute it with scipy.spatial convex hull. Convex hulls are fundamental in fields like clustering, collisions detection, and computer visions, interactions, and containment. You can check if a point lies inside a shape or if two shapes interact using Shapely. This is incredibly useful for spatial analysis like checking if a GPS location is inside a specific zone. Spatial queries and KD tree. When you have a large data sets of points, especially efficiency becomes important. That's where KD tree from scipy.spatial comes in. So computational geometry focuses on solving spatial problems with algorithm. Python supports this through libraries like Math, Shapely, scipy.spatial, and sympy. You can easily compute distances, interactions, polygons, convex hulls, and more. Thanks for watching this video.